types of drugs, which is a problem. And we'll talk more about that later on when we talk about our research. So another thing that we found was there are a lot of things that, in the InfoSec community that we take for granted that just are not present within computational biology. For example, a lot of the publicly available databases are federally funded programs for PhD candidates, postdocs, and for them to publish, they have to make their data publicly available so people can replicate the results, right? A lot of this is never touched after it's published. So you have these very old databases that are just hanging out. And when we were doing our analysis on essential genes in E. coli, we actually found one database that allowed us to use raw SQL queries against it. Unstandardized, untokenized. I mean, they felt that this was okay because, you're trying to get essential data or essential gene data. Who would try to do anything wrong from that, right? Of course. And across the board, we saw that there was no standardization happening, at a lot of these databases.
Ready?
When was the last time any of these were audited? Who knows that, if you're not going to this, that you're not going to get a drive-by, right?
Well, that's a failure.
So this is an inherent problem in the community. If any of you are interested in downloading some of the models that we use, such as E. coli metabolic model, it's available off of the big website. And as you'll see a lot of the data off of here, you'll notice the lack of a checksum, right? So people are using this publicly available data as the foundation of their research. If you can't verify the integrity at the ground level of the computational biology files that you're using, it brings into question all of the results that you have at the end. So this is an enormous problem, right? You have all these publications, but there's no talk of data integrity at the ground level.
Deep breath in.
Right. So another problem isn't a problem right now, but it will be probably in the future with the advances of precision medicine. So you have a whole bunch of genomes and microbiome files just hanging around on research computers.
Yeah.
The problem is your microbiome, which is all the gut and stuff, your bacteria in your gut or other places, your skin or mouth, they're completely unique. So our genomes are extremely similar, right? Like 99.999% similar. Our microbiomes between like me or you is almost, it's unique. It's completely unique. So it's a unique identifier. And right now it's just chilling on researchers' computers, which is a problem. So.
Yeah, so, with that, because there isn't an immediate privacy implication of having microbiome sitting unencrypted on someone's hard drive, there's not an urgency to say, hey, this needs to be encrypted, data at rest. How are you protecting this when you're transmitting it from, the sample that I take when you come visit me in the medical field to a researcher over at, where we study. Why is that not secured in transit? In 10 years from now, when all this data is being exploited and extracted from computer science networks, there's now a wealth of data available to you. What you ate last night, what you've been doing over the past 10 years. Who knows how this data can be used in the future.
So our research focuses on different pathogens. For example, one would be E. coli, which is a common UTI infection, and also you can sometimes find it in unwashed Chipotle food. But specifically, we were looking at pathogens that have become resistant to antibiotics.